Namaste students. Today I am going to teach you subject mathematics. In mathematics we will study chapter number 3, circle. Let us study about circle passing through 1, 2, 3 points. Circles touching each other, inscribed angle and intercepted arc. Second tangent angle theorem, second in tangent, arc of a circle, cyclic quadrilateral and theorem of intersecting chords. Circle passing through 1, 2, 3 points. In the adjoining figure, point A lies in a plane. All the three circles with center P, Q, R pass through point A. How many more such circles may pass through point A? If your answer is many or innumerable, it is correct. Infinite number of circles pass through a point. Infinite circle pass through a one point. Infinite circle pass through two distinct points. There is a unique circle passing through three non-collinear points. Fourth point here, no circle can pass through three collinear points. Second and tangent. Observe these figures. In the figure above, not a single point is common in line L and circle with center A. Observe this figure. This is a circle, this is a line L. There is no common point between these two things. Then point P is common to both line M and circle with center B. Here is point P is common between this line M and circle with center B. Here line M is called a tangent of the circle and point P is called the point of contact. 2 points Q and R are common to both line N and the circle with center C. See here, this is a circle with center C and line N intersect the circle in two distinct points Q and R. Q and R are intersecting points of line N and the circle. Line N is called the secant of the circle. Remember, these are very important points. First here, tangent theorem. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Second, a line perpendicular to a radius at its point on the circle is the tangent to the circle. Third, tangent segment drawn from an external point to a circle are congruent. We will study here tangent segment theorem. Statement here, tangent segments drawn from an external point to a circle are congruent. What is given to us? In a figure, A is the center of the circle, segment PD and segment QD are two tangents. See this figure. A is the center of the circle and segment PD and segment QD are two tangents to the circle. To prove segment PD is congruent to segment QD. Segment PD is congruent to segment QD. Proof: in triangle APD and triangle AQD. Triangle APD and triangle AQD. Segment AP is congruent to segment AQ. The segment AP is congruent to segment AQ. Why? Radii of the same circle. angle APD is equal to angle AQD is equal to 90 degree. Angle APD is equal to angle AQD is equal to 90 degree. Reason: the tangent radius perpendicular relation or theorem. Segment AD is congruent to segment AD. The segment AD is congruent to segment AD. Common side. Therefore, triangle APD congruent to triangle AQD. Hypotenuse side congruency test. And therefore, segment PD is congruent to segment QD by corresponding sides of congruent triangle CSCT. Next here, example: segment REM and segment RN are tangent segment to a circle with center O. Prove that segment OR bisect angle MRN as well as angle MON. See this figure. Here is the solution. In triangle OMR and triangle ONR, segment OM is congruent to segment ON. This segment OM is congruent to segment ON, radii of circle. Segment OR is congruent to segment OR. Segment OR is congruent to segment OR. Common side. Segment MR is congruent to segment ENR. Segment MR is congruent to segment ENR. Tangent segment theorem. Therefore, triangle OMR is congruent to triangle ONR. Yes, congruency test. Therefore, angle MOR is equal to angle. Therefore, angle MOR is equal to angle NOR. Corresponding angles of congruent triangles. Segment OR bisect angle MRN as well as angle MON. Remember this. The point of contact of the touching circle lies on the line joining their centers. If the circles touch each other externally, distance between their centers is equal to the sum of their radii. The distance between the centers of the circles touching internally is equal to the difference of their radii. Here, first, two circles having radii 3.5 cm and 4.8 cm touch each other externally. Find the distance between their centers. Here, radius of one circle is equal to R is equal to 3.5 cm. The radius of another circle R is equal to 4.8 cm. The given circle touching each other externally. Distance between their center is equal to R plus R by theorem of touching circles is equal to 3.5 plus 4.8 is equal to 8.3 centimeter. Means distance between their centers is equal to 8.3 centimeters. To here, the circles of radii 5.5 centimeter and 4.2 centimeter touch each other internally. Find the distance between their centers. Here, radius of one circle R is equal to 5.5 centimeter. Radius of another circle is R is equal to 4.2 centimeter. Here, 5.5 is greater than 4.2, means this capital R means this radius is greater than small r. The given circles touching each other internally. Distance between their centers is equal to R minus R by the theorem of touching circles. Here, value of this R is equal to 5.5 minus 4.2, we will get here 1.3 centimeter. Distance between their centers is equal to 1.3 centimeter. In figure, the circle with center P and Q touch each other at R. A line passing through R meets the circle at A and B respectively. Prove that first, segment AP is parallel to segment BQ. Triangle APR is similar to triangle RQB. And 3. Find RQB and measure of angle RQB if angle PAR is equal to 35 degree. See this figure. Solution. The circles with center P and Q touch each other at R by theorem of touching circles. In triangle PAR, segment PA is equal to segment PR. Segment PA is equal to segment PR. Radii of the same circle. Therefore, angle PRA is congruent to angle PAR by isosceles triangle theorem. This triangle APR is isosceles triangle, and therefore AP is equal to this angle is equal to this angle. Similarly, in triangle QBR, segment QR is equal to segment QB, radii of the same circle. Therefore, angle RBQ is congruent to angle QRB, isosceles triangle theorem. But statement number 3, angle PRA, this angle PRA is congruent to angle QRB. Why? Vertically opposite angles. Therefore, angle PAR is congruent to angle RBQ. But there are a pair of alternate angles formed by transversal AB on segment AP and segment BQ. Therefore, segment AP is parallel to segment BQ. Alternate angle test. In triangle APR and triangle RQB, angle PAR is congruent to angle QRB from 1 and 3. Angle APR is congruent to angle RQB. Alternate angles. Therefore, triangle APR is similar to triangle RQB by a similarity test. Angle PAR is equal to 35 degree, that is given. Therefore, angle RBQ is equal to angle PAR is equal to 35 degree. In triangle RQB, sum of the measures of all angles of triangle is 180 degree. Therefore, angle RQB plus angle RBQ plus angle QRB is equal to 180 degree. Therefore, angle RQB plus angle RBQ plus angle RBQ is equal to 180 degree. Therefore, angle RQB plus 2 times angle RBQ is equal to 180 degree. Therefore, angle RBQ plus 2 multiplied by 35 degree is equal to 180 degree. Therefore, angle RQB plus 70 degree is equal to 180 degree. Therefore, angle RQB is equal to 110 degree.